Hello everyone. We are going to solve our first example number 1. We have x and y axes, but we have a rectangular section with width b equal to 4.4 meters and the height is 0.6. This rectangle is apart from the y-axis by distance of 0.2. You are required to estimate the following for the given rectangle: ix and kx radius of gyration at x-axis, and b, we want to estimate the moment of inertia at y-axis and the radius of gyration for the y-axis. First, we have our x and y external axes. As we know that ix equal to the ix g plus the area multiplied by y squared. So we have for the moment of inertia about the CG for the rectangle section, we have b multiplied by h cubed over 12. Then we have this moment of inertia here at x passing by the CG. We want to get the expression for x axis. We have to add the product of area multiplied by y squared. First, our bh cubed over 12 will be equal to 0.4 multiplied by 0.6 raised to the power of 3 divided by 12, which will give us 0.0072 m power of 4. Our area already is 0.4 by 0.6, which is 0.24 meter square. For the item A, y squared, y bar square, we have A bh and y bar is h over 2, all raised to the power of 2. So we have bh, which is 0.4 by 0.6, multiplied by h over 2 raised to the power of 2. H over 2 is 0.3 raised to the power 2 divided by 4. This will give us 0.0216. So our required moment of inertia about x-axis will be the summation of these two items. First item is ix at g, at the CG, which is equal to 0.0072, plus the ay bar square, which is equal to 0.0216. Adding both will give us 0.0288 m to 4. While for the expression of radius of gyration for x, we have k squared x equal to ix divided by the area. Our ix already obtained as 0.288 divided by the area, which is 0.24. So the k squared x equal to 3 over 25. We can get the kx by taking the square root of 3 over 25, which will give us square root of 3 divided by 5, which is equal to 0.3464. We have dimension, this is meter, because for the moment of inertia is m to the power of 4, and the area is m to the square. We take, if we divide them together by each other, we have m squared. We take the square root of m squared, will give us meter. We proceed for the moment of inertia for the y. The moment of inertia for the y equal to the moment of inertia about the CG for y, plus the area multiplied by x bar squared. The moment of inertia at g equal to h multiplied by b cubed divided by 12. Our h is 0.6, our b is 0.4 raised to the power of 3, all divided by 12 will give us 0.0032 m4. Our area is still the same, 0.24. For the a multiplied by x bar square, 0.24 by our x bar in this regard, it will be 0.2 plus half of 0.4, which will, as a total is 0.4. We raise it to the power of 2. We will obtain 0.0384 m4. So our IY is a summation of both two terms. The first term equal to 0.0032 plus our ax bar square equal to 0.0384. It will give us 0.0416. So our ky is the square root of the I divided by the area. Our I is 0.0416 over 24.24. All under the square will give us 0.416. Thanks a lot and see you in the next example. Goodbye.